Hello, this video is about running graphical applications in a container in a virtual machines that expose their windows on the host compositor that should work seamlessly across multiple monitors. Here we have a diagram showing the composition of the solution. On the host we are running the Wayland compositor and Waypipe in the container. In the virtual machine we are running container with Waypipe and application. Waypipe exposes host Wayland compositor to the application container, and this works by running one Waypipe instance, listening on vSock on the host, and running another Waypipe instance which provides proxy Wayland server for the application. So the connection to the Wayland for the application goes through one Waypipe, through vSock, to the other Waypipe, and this renders it on the host compositor. Waypipe is not focused on security, but it should work for proof of concept solution. And it still provides some isolation of the application because it's running in a container in a virtual machine. So Waypipe is probably the only attack surface along with the Wayland compositor because it proxies all protocols. Now we are going to try this. And I'd like to add that I managed to freeze my machine by doing this and more experiments. I don't know what went wrong, probably just I ran out of memory, or I don't know, but just a warning, save your work if you are going to try this. So now we are going to do this. First we will download Fedora base image, which I have already done. So we'll just copy it. Now we will create this image based on this Fedora Cloud based image for the virtual machine. Next we will create metadata files which contain the name, username and password and some other stuff, and create ISO image out of this. Don't have installed this globally, and we will create ISO image out of these files so virtual machine will be properly initialized. Now we have these images created and we can start the virtual machine. And it's running. It will take some time. For this command, I will explain it. We are running on QEMU virtualization, 4 threads, 4 gigabytes of memory. Here we have metadata, ISO mounted, disk, and vhost device, and without graphics because we will proxy graphics to the host compositor. Okay, so it's starting in the meantime. And we will create a Docker file for Chromium browser. It also contains the default command which runs Waypipe, connects into vSock on fixed port 1234, and which runs Chromium without sandbox on Wayland platform. We will create a similar file for the Firefox. Similar also runs Waypipe, which runs Firefox, and Firefox install Waypipe and some utilities for experimentation. Now we will build images based on those definitions with Podman. This will take some time because it downloads lots of stuff on my not so fast internet. In the meantime, we prepare stuff on the host. So an image for running Waypipe in a container. So we will create Docker file with the Waypipe image definition. This contains just Waypipe and user creation. I want to run it without GPU, so less features. And it will run on vSock on hardcoded socket. This is actually a listener which provides Wayland from the host to the VM, but from Wayland perspective, it's actually client on the host, and the other one is server in the VM. This is still building, and we will build the image on the host for the Waypipe, which I had already cached because I had built it before. Okay, this is still building. We can start by running Waypipe on the host to expose the Wayland, but for this you need to have VSOC mode probed, which you can run with this with sudo. Let's just uncomment it. I have it already mode probed. And so now we will run the container to expose Waypipe. We need to mount few things. vhost, set some environment variables for the XTG runtime and Wayland display, and also mount the Wayland display from the host, and keep this same user ID so Waypipe doesn't have issue to connecting to Wayland socket on the host. Now it's running. And this is finally built, so we will build the second image for the Firefox. This will again take some time. On the host we have everything prepared. So it's done. Now we can run containers from those images. We'll run Chromium first. We need to expose the device for VSOC and set the runtime directory. And it launched. So we can run test UFO. And this is using software only rendering, because it's running in the virtual machine with no acceleration. And it managed to get 60 FPS almost. For simplicity. Another thing, we will run Firefox. And both are running. And quite fast. So if we kill those containers, for example, we kill the Chromium one. This doesn't work. Kill does work. So it was killed. And okay, we also stop the Firefox. And we have no containers anymore. We will run Chromium again. And this should work seamlessly across multiple monitors. So I will now try to record multiple monitors. I will see whether I succeed. So I succeeded in adding another display to the recording, and we'll now run another window. of the Chrome, and also show the test UFO. And we see that it actually works nicely with different FPS displays. So I think works nice even if it doesn't show, it's not supported, consistent. Okay, this is actually a continuation from my previous experiment, which runs stuff in the container. Now it's running in a container in a virtual machine, so a bit more isolation. And we will try to kill this. Okay, so it stopped. And we see it works quite nicely. That's it. Thank you for watching. Hope you enjoyed the video. Let me know what you think about this approach, whether you like it. And if you have any ideas or suggestions, feel free to comment. I will be glad to hear them, read them. So thank you. Bye.